Okay, so today we are applying the heat formula. So just to go over it, I have some paper here just because I don't know how much space I'm gonna have. Don't mind me. So the formula that we're gonna be using is Q equals MC delta T, okay? Q is going to equal heat. This is going to be shown in either calories or joules. M is going to be mass, and you're going to see this in terms of grams. C is going to be specific heat, and the way you're going to see that is either joules over grams Celsius or calorie, there should be a lowercase c, calorie grams Celsius, okay? Ooh, sorry. If they don't give you this number, it's because it's going to be water. And for water, it's going to be 4.18 joules over grams Celsius, or 1 calorie over grams Celsius, okay? And then delta T is basically going to be change in temperature. So you'll do the final temperature that is given to you minus initial, and whatever number you get is what you're going to plug in for that, okay? So let's work out a couple problems. Number 1 said, how much heat is required in calories to raise the temperature of 57.8 grams of silver from 17 degrees Celsius to 43.5 degrees Celsius? If the specific heat of silver is 0.057 calories over grams Celsius. I like to list everything out. My Q is what I'm looking for. My mass is going to be 57.8 grams. My C is going to be 0.057 calories over grams Celsius. Ooh. Grams Celsius. And then my change in temperature is going to be 43.5 minus 17, which is going to give me 26.5 degrees Celsius. Okay, now let's plug it in. Q equals 57.8 grams times my specific heat, which is 0.057 calories over grams Celsius. Okay, and then you're gonna multiply that also by the change in temperature, which is going to be 26.5 degrees Celsius. You want to make sure you include all your units in your formula. Now start canceling what you can. You got a grams here, grams there, that cancels. This Celsius and this Celsius are going to cancel. So you're left with Q equaling 57.8 times 0.057 calories times 26.5. Okay, plug that into your calculator, and you're going to get 57.8 times 0.057 times 26.5. Q is going to equal 87. Let's round that to 3. This is heat, so heat is going to be in either calories or joules. The question here is telling you calories, and the units also gives you calories. So it's going to be calories. Okay. Let's look at the next question. It says, how much heat in joules is required to raise the temperature of 1.82 kilograms of water by 3.32 degrees Celsius? So our heat is what we're looking for based on the question. Our mass is going to be 1.82 kilograms. Mass is always going to be listed as grams, so we need to convert this. So let's just do that now. Okay, 1 kilogram down at the bottom times 1,000 grams. This cancels, that cancels, so we are left with 1,820 grams of water. Our specific heat is not given to us, but it's in your notes, okay? So make sure you remember those. So the specific heat in water, or for water, in joules, because that's the unit that we're looking at, is going to be 4.18 joules over grams Celsius. And then the temperature, since they only gave us one and the question is not specifically asking for temperature, they already gave you the temperature change, okay? So it'll be 3.32 degrees Celsius. Now, plug in what you know. Q is going to equal 1,820 grams times 4.18 joules over grams Celsius times 3.32 degrees Celsius. This will cancel with this will cancel with this, until you're left with only the units that you want, which is going to be joules. So you are plugging in 1,820 times 4.18 times 3.32, and you will get 25257 we'll just round that to 2 joules. So you will get 25,257.2 joules. Okay, let's look at the next one. It says, what is the mass of alcohol, or what is the mass of a sample of alcohol with the specific heat of 2.4 joules if it requires 4,780 joules of heat to raise the temperature by 5.43 degrees Celsius? Let's set up what we know. So for this, you have to read the question because it might get a little tricky to figure out what's what. So we have heat, mass, specific heat, temperature. So remember, heat is going to be in joules or calories. The only thing here that you have that is only in joules or calories is going to be this number. So that is our heat. And we're looking at it in terms of joules. We are looking for the mass, so we're not going to have what M is. It tells you the specific heat right here, so 2.4 joules times grams Celsius, and then your temperature is going to be 5.43 degrees Celsius. Okay, sorry. This tripod thing is a little weird. I'm so sorry. Okay. Now just plug it in. So here's the formula. I'm going to isolate the letter that I'm trying to plug in just so it's easier. So right now we are looking for M. So I'm going to get M by itself. So Q equals mass times specific heat times temperature. I want M by itself. These other two variables, the C and the temperature, they're multiplying with the mass. So to get rid of them, I'm going to send them over dividing. Okay, this is just basic algebra. We're canceling that. What I do to one side, I have to do to the other. So I am dividing it on the other side. So the formula I am left with is M equals Q over C times the temperature change. Now this formula, I'm going to plug in all my information. M equals, we're going this way, 4780 joules over 2.4 joules grams Celsius times 5.43 degrees Celsius. Cancel out the units that you can. This temperature is going to cancel with this temperature. This joule is canceling with this joule until I'm only left with the units I want, which is going to be grams. So I'm going to do 2.4 times 5.43, and that's going to give me my denominator. So M equals 4780 over 13.032 grams. I'm going to solve for this. 4780 divided by 13.032 is going to give me 366.4 we'll do 8, and this is grams. Okay? Let's do the next one. Okay. We're solving for specific heat. Specific heat. So, very similar to the last one, I am going to solve for C. Okay? Actually, let's list off everything first. Q, M, C, delta T. This should have said delta, sorry. Okay. What is the specific heat of iron if it requires 1,050 joules of heat energy to raise the temperature of 220 grams of iron from 10 degrees Celsius to 20.4 degrees Celsius? Okay. So, this is in joules, which I know is going to be my heat. So, 1050. Mass is going to be 220 grams. You want to make sure you're paying attention to the units because that's going to be the easiest way to solve for it. I don't have specific heat, that is what I'm looking for. And for my temperature, I'm doing my final 20.4 degrees Celsius minus my initial 10 degrees Celsius, and that's going to give me 10.4 degrees Celsius. I'm trying to solve for C, and very similar to the last one, M and the temperature are being multiplied by the specific heat. So to get rid of it, we got to send it over dividing. So Q equals MC delta T. I'm getting rid of the M and I'm getting rid of the delta T. This cancels, these cancel. What I do to one side, I got to send over to the other side. So M times the change of temperature. So I'm left with C equals Q over mass times temperature. Now plug in what you know. 1050 joules over 220 grams times 10.4 degrees Celsius. We'll put that in parentheses. There's no units to cancel, so you're going to leave it, which is okay because specific heat, these are the 3 units you need. So I'm going to try to make my denominator look a little bit better. 220 times 10.4 is going to give me 2,288. So 1050 joules over 2,288 grams Celsius. I'm going to do, it's going to give me 0.46 joules over grams Celsius. And that is my specific heat. Okay? 5. What is the temperature change on a 75-gram sample of mercury? Let's move that a little bit. So it gives me my specific heat of mercury, it gives me my calories of heat, and we got to figure out what the temperature change is. We said our heat is 480 calories. My mass is going to be 75 grams. My specific heat is 0.033 calorie over grams Celsius. And I am looking for my temperature. Okay? So I'm going to get temperature by itself. We've already isolated the 2 other ones before, so I'm not even going to work that one out. Change in temperature is going to equal heat over mass and specific heat. So 480 calories over 75 grams times 0.033 calorie over grams Celsius. Cancel my units. So I'm going to do 480 over 75 times 0.033. It's going to give me 2.475 degrees Celsius. Okay, then I'm going to do 480 divided by 2.475 is going to give me 193.9 degrees Celsius. And that is my temperature change. This would be my C. Okay. Okay, so I am not going to do this one because here it's asking for heat, which is basically going to be Q, and we've already solved a problem for Q already. This one is specific heat, so similar to the one that we did on the first side. Mass we have solved for. I'll do 9 with you, and then I'll post the key to the rest of them, just to make sure you understand it. But a lot of these are just practicing the same skills that we did on the first side of the page. So this one says, if 2,035 calories of heat is added to 500-gram sample of water at 35 degrees Celsius, what is the final temperature of the water? So you're giving you the initial and they need the final. So what we're gonna do is we're just gonna solve for the temperature and then we'll go from there. So Q is gonna be 2,035 grams, or I'm sorry, what is this? Calories. Our mass is gonna be 500. Our specific heat, it's water, and we're using calories, so it's gonna be 1 calorie over grams per Celsius, and then our temperature is going to be what we're looking for. So similar to how we did the other ones, we're gonna isolate temperature. So temperature is gonna equal heat over mass and specific heat. So 2,035 calories over 500 grams and 1 calorie over grams Celsius. This calorie cancels with this gram cancels with this. 500 times 1 is still going to be 500, so you're going to do 2,035 over 500. We're only left with this, so then we're going to divide 2,035 divided by 500 is going to give us 4.07 degrees Celsius. So this is the change in temperature. We are going to do, but now we got to figure out the final. So we have, so this number is actually going to equal delta T. So we're going to do 4.07 degrees Celsius is going to equal final minus our initial. The initial was given to us at 35 degrees Celsius. Woo. So to solve for this, and this is subtracting, we just got to send it over to the other side adding in order to cancel out. So that will cancel. So you do 4.07 plus 35.0 degrees Celsius is going to give you 39.07 degrees Celsius as our final. Easy enough?